Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at factorizing quadratics. A quadratic is an expression of the form ax squared plus bx plus c. Basically, it has this x squared term and it may also have an x term. So if I want to solve an equation like this, it's actually very difficult to get the x by itself. So we can't solve them like we solve linear equations. The way that we're going to solve a quadratic equation like this is to factorize it. So when I factorize the expression in blue, it actually turns into x minus 6, x plus 5. Now, when we factorize quadratic equations, they're super easy to solve. We can use what's called the null factor law, which tells us that if you have something times something equals 0, either the first something equals 0, so if x minus 6 equals 0, we have x equals 6. And if x plus 5 equals 0, we have x equals minus 5. They are the two solutions. Now, we're actually not going through solving in this video. I just wanted to show you where we're going. See, this expression and this expression, they are equivalent. To go from this to this, I have factorized. Factorize means to write an expression as something times something, and that's very useful with quadratics because we can use the null factor law. Factorizing is the opposite of expanding. Factorizing and expanding undo each other just like multiplication and division or like addition and subtraction. If I were to expand this using FOIL, I would get this. Okay, so how do we factorize quadratics, that is, expressions that have this x squared term? Well, unfortunately, we need different methods depending on what the quadratic looks like. So if the quadratic has two terms, in which case we say it's a quadratic binomial, we either use the highest common factor or dots, which is difference of two squares. If it looks like this, we use highest common factor, and this we use difference of two squares. So when you're factorizing a quadratic, always first ask yourself if there is a common factor. So if we have something like x squared minus 8x, that is a quadratic binomial that looks a bit like this. Here a is 1, b is negative 8. So to do highest common factor, you take the highest common factor out the front, then you write some brackets. We divide each of the two terms by this common factor. So what do I times by x to get x squared? Well, you times x by itself to get x squared. What do we times by x to get negative 8x? Well, that's just negative 8. So if I were to expand this, I would get that. That's how you use highest common factor. So let's say we had something like x squared minus 49. That is a quadratic binomial that looks a bit more like this one. So here, neither term shares a common factor. So we're going to use difference of two squares. It's so called because we have a perfect square minus a perfect square. This is how you do difference of two squares. You get two brackets, square root the first, put it in each bracket, square root the second, so square root of 49 is 7. One bracket gets a plus, one gets a minus. If I were to expand this, I would get that. So we're done. We've written this expression as something times something. So sometimes we will have to use both of the methods. So in order to avoid confusion, just always ask yourself, is there a common factor? Between this term and this term, the common factor is 5. So I put 5 out the front. What do I times by 5 to get 20x squared? We times it by 4 to get 20 and x squared to get x squared. What do I times by 5 to get negative 5? You times it by negative 1. Now this thing here in the brackets is the difference of two squares. This is a perfect square, so too this is a perfect square. So I'm going to leave the 5 alone. This is how we do difference of two squares. Two brackets, square root the first, so square root of 4x squared is 2x. Square root the second, one bracket gets a plus, one gets a minus. If I were to expand this, I would get that. So just be careful, this is the difference of two squares. Difference means minus or subtract. We actually don't have a method for factorising the sum of squares. So something like x squared plus 4, yes, we've got perfect square and perfect square, but it's the sum, not the difference of two squares. We don't have a method to factorise that, so you don't need to worry about those now. Okay, let's look at trinomials. So they're quadratics with three terms. They look like this. So the way that we factorise trinomials is different depending on whether it's monic or non-monic. Monic meaning a, this coefficient of x squared is 1. I'm going to go through a few examples of this. This one's a bit more complicated and harder, so it gets its own video and its own lesson. So here we have a monic trinomial. It's monic because the coefficient of x squared, if not written, is assumed to be 1. X squared and 1x squared are the same thing. So this is monic and it has 1, 2, 3 terms. For that, we use product sum rule. We need to find two numbers that multiply to this constant term, the term with no x's, and they add to this middle coefficient. So what we do is we set up two brackets. So we want two numbers that multiply to 9 and add to 6. So they are 3 and 3. 3 times 3 is 9. 3 plus 3 is 6. So once again, we've factorized. We've written this as something times something. If I expand this, I get that. So just for this particular one, we can write it as x plus 3 all squared. All right, let's do another example. So we're now going to factorize x squared minus 2x minus 48. This is a quadratic because of the x squared. It is a trinomial because there are three terms, and it's monic because this coefficient of x squared is 1. The way we factorize monic quadratic trinomials, we get two brackets. We need to find two numbers that multiply to this number and add to this number. So we always put the x in each bracket like this. Now the two numbers that multiply not to 48 but to negative 48 and add to negative 2. Well, let's go through the factors of 48. So 48 and 1 doesn't work, so too 2 and 24, 3 and 16, 4 and 12, they don't work, but 6 and 8 will work. So how are we going to get 6 and 8 to add to negative 2? We need to make the 8 negative and the 6 positive. 6 times negative 8 is negative 48. 6 plus negative 8 is negative 2. Once again, we have written this expression as something times something. That is what factorizing is. Factorizing is the opposite to expanding. If I expand this, I get that. So again, where we're going with this will allow us to solve quadratic equations, as it will allow us to use the null factor law. So this method will be covered in a separate video. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.